In this video, we're going to talk about a variety of statistical graphs that you are going to learn how to read and interpret for results. So the first graph we're going to talk about is called a scatter plot. When you're looking at a scatter plot, it is a group of points that have been graphed that have no direct equation that represents them, but have a general, what we're going to call correlation. So that's what we're going to talk about first, is how we talk about the different types of correlation of a scatter plot. So in the first example, right here, we have an example of a scatter plot with positive correlation. And that's because as my x gets bigger, so does my y. So we notice the points are going in the upward direction. So this is an example of what a scatter plot with a positive correlation would look like. Underneath it says example. What this means is give me an example of an event that has a positive correlation. So one example would be the more hours you study, the higher your test score will be. So this is an example of positive correlation because as the number of hours of studying increases, the value or the score on your test will go up. The second is example of negative correlation. It's negative correlation because as my x gets bigger, my y values are actually getting smaller. So we're going down, we're going in the downward direction. So an example of negative correlation in real life would be like the more days you exercise, the less you'll weigh, in theory. So an example would be, so I'm exercising more days. So the more days I exercise, the less I will weigh. So in theory, the more days, so as the days increase, my weight will decrease. So that's an example of negative correlation. This last one is no correlation. And that's because if we look at this last graph, as x increases, y really has no relationship. Those points are kind of all over the place. So, for example, this is kind of a silly example, but it'd be the number of ice cream cones you eat in a week and your shoe size. So those things aren't correlated. There's no relationship between the amount of ice cream you eat and your shoe size. So these are some examples of positive, negative, and no correlation. So let's go down and look at number 1 now. It says the number of knots tied in a rope and the length of the rope. And they want to say if it's positive, negative, or no correlation. So if I'm tying knots in a rope, and what's going to happen to the length of the rope? Well, as I tie knots in a rope, the length of my rope is going to go down. So the more knots I tie, the less rope I'm going to have. So this is an example of negative correlation. Number 2, it says the height of a woman and her score on an algebra test. Well, there's really no correlation between those things because no matter how tall or short you are, it doesn't affect how you'll do in algebra. So there's no correlation with that. So let's scroll down and now we're going to look at some graphs and we're going to say whether they're negative or positive correlation. So if I look at 3 and 4, in number 3, I can see that in general my data is trending downward. So this is going to have a negative correlation because as my x's are getting bigger, my y's are getting smaller. In number 4, we're seeing the opposite. I'm seeing an increase. So it's saying as your height increases, so does your femur length, which would make sense because typically your legs are going to be longer if you're taller. So that's going to be a positive correlation. All right, so now we're going to move on from scatter plots to frequency tables. Like I said, we're going to talk about a lot of different types of graphs and tables in this example. So in a frequency table, on the left side is your categories or your ranges. So in this case, in this table, I have batting averages. So batting average from 0 to 0.199, and so on and so forth. The right side is the frequency, or basically the number of times that batting average occurs. So this saying on a baseball team, I have 8 players whose batting average is between 0 and 0.199, and then 10 players in the next range, 6 players in the next range, 2, and then 1. So it's saying how many players' batting averages are in that range. So a lot of times it's going to give us a table, and then it's going to ask us some questions about it. So the first question says, how many baseball players had an average of at least 0.2? All right, so we have to be able to know what at least means. At least means that it's 0.2 and above. That means the smallest was 0.2. So which ones apply to that? Well, 0.2 and above would be this guy plus this guy plus this guy plus this guy, because it's at least 0.2. So I'm going to add those up, and I know that I have 19 players that have at least a batting average of 0.2. The next question says, how many players have an average of between 0.4 and 0.599? Well, if I look at my table, I can find that average, which is right here, and the answer would be 6. The final question says, how many total players are there? Well, total players come from adding up all the frequency. So I would add all of the frequency together, and I would do 8 plus 10 plus 6 plus 2, and I would get 27. All right, the next type of chart we're going to look at is a bar chart. I'm going to zoom in for you on this one. Now, bar graphs are something we should be very familiar with. So I'd like you to pause the video now and read questions 1 through 10 and see if you can answer them without my help. Then play the video and see if you got your answers right. All right, so for question number 1, we should have already had these answers filled out to the best of our ability. So we're just going to go through and answer them kind of quickly. Question 1 says, how many people voted for Ice Age? The answer is 5, because I look at the Ice Age bar chart and it's 5. 2 says, did more people vote for Ice Age than Up? And the answer is Up. More people voted for the movie Up. 3 says, did fewer students vote for Cars or for Brave? Fewer students voted for Cars. 4, which movie received exactly 10 votes? That would be the movie Up. 5 says, what is the difference in the number of people that voted for Brave and the number that voted for Spy Kids? So the difference between the number of kids that voted for Brave and the number of kids that voted for Spy Kids is 1. Question 6 says, what is the combined number of people who voted for Up and Brave? So Up and Brave, if I added those together, I would get 17. Question 7 says, which movie received the most votes? The movie that received the most votes was Up. Question 8 says, which movie received the fewest votes? Cars received the fewest votes. Question 9 says, how many more votes did Spy Kids get than Brave? Spy Kids got 1 more vote than Brave. And number 10 says, how many fewer votes does Ice Age receive than Up? Ice Age got 5 fewer votes than Up. So we should be pretty good at reading our bar charts. And so now we're going to move on to another type of graph. The next graph we're going to go over is histograms. Now histograms look kind of like bar charts, but the histograms actually represent a range. And actually histograms usually go with the frequency table, because you can see that I'm going to have a range here. I have from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Now, what you have to realize is that histograms are a little tricky. This first box is really going from 0 to like 1.9. The next one goes from 2 to 3.9. The next one goes from 4 to 5.9, and so on and so forth. So you have to realize that that next number is always referring to the next table, not that current table. And so this one's really 8 to 10, because 10 is where we end. So that 2 is always referring to the next one, the 4 is referring to the next one. So keep that in mind when we answer these questions. 1 says, most students received between blank and blank gifts. So basically, which frequency was the highest? The highest was 4 to 6 gifts. Now, if you wrote 4 to 5.9, that's okay too, but really that range is kind of 4 to 6. But keep in mind that if they ask which one 6 fell into, it would fall into this one, not this one. All right. Number 2 says, how many students received 8 to 10 gifts? If I look at my chart, it's right here, which would be 4. So 4 people. Question 3 says, how many students are represented in the histogram? So we're looking at how many total students. So I got to add. So his first bar is 3, 4, and then 7, 5, and 4. So now I got to add those together. So 3 plus 4 is 7, plus 7 is 14, plus 5 is 19, plus 4 is 23. Question 4 says, if a student receives 6 gifts, which bar graph would it be added to? So again, this is where we have to talk about. 6 would fall into this range. So it would not fall into the 4 to 6 range, which I know seems a little confusing, but the number always starts with the next interval. So it would fall in the 6 to 8 range. All right, there's a second histogram down here. I'd like you to pause the video now and attempt to answer these questions on your own. When you're ready, play the video and see if you got the questions right. All right, now that you've tried these on your own, let's answer these questions. 5 says, most students scored between a blank and a blank. Well, the answer would be between 70 and 79. How many students scored between a 70 and 79? Well, if I look up here, it's at 10, so 10 students. 7 says, how many students are represented in the histogram? All right, gotta add these up. 5, 2, 10, 1, 1. So 5 plus 2 is 7, plus 10 is 17, plus 1 is 19. Then it says, if a student scored an 89, which would it be added to? So this one's actually a little different, and they actually said 50 to 59, 60 to 69. So I can see that would fall in the 80 to 89 range. But keep in mind, always be careful about when it asks those types of questions. The type of chart we're going to look at is something called a stem and leaf plot. Now, a stem and leaf plot shows us a list of numbers, just more in an organized fashion than a list. So what a stem and leaf plot does is, in this case, like the stem is like the tenths or the hundredths place, and the leaf is the ones place. So when I'm looking at this first list, I have 9, 0, and 5. So what this means is I actually have 90, because I have 9 as the tens place, and then 0 as the ones place, and then I have 9 as the tens place, and 5 as the ones place. So the stem and leaf plot, this first row, is 90 and 95. Then I'm going to do the same thing. Now these are 10 plus all these numbers. So these are going to be in the hundreds. So 10 and a 0 would be 100. 10 and another 0 would be 100. 10 and another 0 would be 100. Then I have 10 and a 4, so that'd be 104. And then I have 10 and an 8, so that'd be 108. Now I have 11, so I have 11 and a 0, so that'd be 110. And then I have 1, 2, 3, 4 more of those. So I have 5 total 110s. And then I'm going to go on to, I'm going to have 3 115s. And then 120 is going to be my last one. So number 2 says, how many lots are at least 110 feet wide? So again, at least means that's the minimum. So I have 1, 2, 3, 4, 5. Well, here, I'll highlight as I count. So 1, 2, 3, 4, 5, 6, 7, 8, 9 that are at least 110. So it's 110 or bigger. What is the mode? Well, the mode is 110. I can see that's the mode. Remember, that means the number that shows up the most often. That's what mode means. So most often is 110. All right. This next stem and leaf plot is similar, but now we're asking a few different questions. So it's going to ask about the range. Your range is always your biggest minus your smallest, or your greatest minus your least. So my biggest ceiling height is 277. My smallest one is 241. So that means my range would be 36. Your median is your middle. So you got to find your middle number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So the middle would be the 5th and the 6th. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So those are the fifth and the sixth number. So in this case, to find the median, I got to average those two middle numbers. So I'm going to have 253 plus 262, all divided by 2. So my median is going to be 257.5. Now again, the mode is the number that shows up the most. And so in this case, that was 253. All right, the mean. The mean is our average. The mean is our average. So the mean height of the ceiling. So that means I have to add them all up and then divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 total. So I got to add 241 plus. So basically I got to add all these together. So when I do that and I add them all together and then I divide by 10, I'm going to get 259 is my mean. Now my last question says, how many ceilings are at least 262 centimeters tall? So again, at least means the minimum. So that's where I'm going to start with. So 262, so that's 1, 2, and then everything above that. So 3, 4, 5. So there are 5 that are at least 262. All right, after stem and leaf plots, we just have 2 more to talk about. The next one we're going to talk about is something called a dot plot. So a dot plot is really just dots that represent how many of each category there are. So this dot plot shows the number of students in each teacher's class. So Mr. or Ms. Adams has 4, Mr. or Ms. Barrera has 3, so on and so forth. Those are the last names, or maybe the first names of the teacher. Not really sure. So this says how many total students are there in all the classes. So I would have to add this up. So I'm going to add 4 plus 3 plus 6 plus 2 plus 1, or not 1, sorry, plus 7, I think 1, 2, 3, 6, 7, 1, 2, 3, 4, 5, 3. So I add all those up and I would get 30 total students. And which class has the least number of students? Well, that's the one with 2, so that'd be Daisy. Which class has the most number of students? Well, that would be Even, or maybe they say Evan, I don't know. All right, let's look at another dot plot. Now this dot plot talks about the number of lemons. So this is where it gets a little confusing now, because now they're talking about this is the number of lemons. So 11, 12, 13, 14, 15, 16, 17 that each person has. So some people have 11, 12, 13, 14 lemons. So how many total individuals are there? Well, each of these boxes represents an individual. So this is 4 individuals, 1, 2, 3, 4, 5, 6, 1, 1, 2, 3, 6, 1, 2, 3, 5, 1, 2, 3. So if I add all those up, the total number of individuals I'm going to have is 28. Now it's saying what's the total number of lemons? So 4 people have 11 lemons. So that means there's 44 lemons here. 3 people have 12 lemons. 6 people have 13 lemons. 1 person has 14 lemons. 6 people have 15 lemons, which means I have 90 for that row or that column. 5 people have 16 lemons, and 3 people have 17 lemons. So these are the total number of lemons for each group. Now I have to add all those together, and when you do, you get 393 lemons. Now we have one more type of data to look at, and that's a box and whisker plot. So we're going to label some parts of this box and whisker plot. So it's called a box and whisker plot because it looks like a box with some whiskers coming out of it. So a box and whisker plot represents a few things. We have a minimum and a maximum. This middle part is actually our median, or the middle of the data. Then we have the either side of the box. So this first side is sometimes called the first, or it's called the lower quartile. So quartile meaning like quarter. This is the third or the upper quartile, or quarter. So again, this is our data is kind of divided into quarters. So think of it kind of like a football game or a basketball game. This is 25% of the data. this is 25% of the data, this is 25% of the data, and this is 25% of the data. So it's split into quarters. Okay, so using that information, let's see if we can answer these questions. It says at which cost is the upper quartile? So we talked about the upper quartile is the top part of the box, and that's going to line us up right at 26. What is the range? Well, the range, again, is our maximum minus our minimum, or our biggest minus our smallest. So in this case, it's going to be 29 minus 7, which would be 22. The next question says, what is the median? So again, the median is that middle point, and so that median lies right here, which I kind of drew all over it, so it's a little bit hard to see. So let's look. So if I were to draw this straight down, it actually looks like it's falling right between 20 and 21, so it looks like our median is 20.5. Which cost represents 100th percentile? Well, the 100th percentile is just another way of saying our maximum, and so in this case, that'd be 29. How many CDs cost between $14.50 and $26.50? So this is where we have to go back and read the directions. It says there are a total of 12 CDs. So we talked about that each quartile is 25% of the data. So what that's telling us is that if I have 12 CDs and it's divided into quarters, that means 3 CDs are in each quarter. So that means 3 are in this quarter, 3 are in this quarter, 3 are in this quarter, 3 are in this quarter. So it's one saying how many fall between 14.50 and 26. Well, 14.50 is this lower quartile, and 26 is this upper quartile. So that means 6 CDs would fall between that first quarter mark and that third quarter mark. And then it says how many CDs cost less than $14.50. So that'd be from that first quarter mark to the minimum, so that'd be 3 CDs. So remember, our quartiles represent a quarter of our data. Since there were 12 CDs, there were 3 CDs, like 3 CD data points in each quarter.